Hello. So in this video you will learn how to implement a Lindenmayer system interpreter, and we'll be doing that in a visual programming language which is called Scribble, and you see that here right in front of us. Scribble is a visual language that looks kind of similar to Scratch that you may have heard of, but it is a little bit different. It's far more powerful. It's really a fully fledged programming language, only that it's visual. The entry point, however, is really easy. And you can then just learn more and more about it as you want to do more powerful things. So Scribble is specifically made to work with turtle graphics, so it's ideal for our purpose here. So the first thing is, of course, that you actually need an installation of Scribble, and you will either have a local one, and how to get that is described in the manual that came with these lessons. But you can also just run it in any normal web browser. So let me call my Google Chrome here, and I go to a URL that we've abbreviated as tinyurl.com/scribble-aws, because it runs on AWS. And you'll see you get exactly the same that I had before, and we'll actually be working on that. And this is a complete working version of Scribble that you can just call up. As I said, we cannot guarantee that that's there forever, unfortunately. So if you can't get it, or if you don't have an internet connection, you first need to get a local installation. Now, the other thing is that this tutorial assumes some familiarity with visual programming, the basic steps. So you may have gathered that for another language, something like Scratch. Or maybe you've used Pencil Draw before. They're all very similar. And you need to have some basic familiarity with that type of language. If you don't have that, there are tutorials that teach you Scribble from scratch, and you can find those as well on the web. So I go to a different tab here. If you go to a site that is called flipt, FLIPT.org, you'll find a number of publications there. Here, the first ones are about Scribble, so there's a complete tutorial and introduction to programming with Scribble, and that's available in various forms. The best form, if you have an iPad or an iPhone or a Mac, would be to use the iBook, and you find that here on the iTunes Store for free download. If you don't have that, you can also download it as a PDF here, and then work with the Scribble app to learn how to use it in general, and then return to this tutorial here. Okay, so now you will have a working version of Scribble in front of you, and we'll start to implement the Lindenmayer system interpreter, and we'll do that in two steps, in two major phases. The first one is that we won't bother about how to generate the actual string that describes the plant, and we'll just assume that we have that. And what we implement is instead just how to draw that string, how to make the visual representation from the description, from the textual description of the plant. And then as a second step, we'll actually worry about how to generate that string, and when we've completed that, we'll have a complete interpreter that can run any Lindenmayer system grammar. So as an example, we'll use something from the lessons, and I've gone in here into that, and you will remember there was this very simple grammar here that generated this type of tree, and that's what we'll be working on. So you may want to call that up again, this example. So let's get started by defining a variable. So we go into the section variable, we'll make a new variable, and we could give that any name. Let's just call it the string, which is what we want to draw. Type that in, press OK. You see it here, and will automatically be displayed up here, the value. So to do anything useful with that, we will need to give it a value. So we grab this set command for variables, set the variable string, and we'll just copy over what we had here where is it? A useful string. We can take this one down here. Don't copy the quotes around it, just the text. Copy, go back here, paste that into that window, and to run that block we just double click it. So you see now the string here has a value. We can get rid of it, we don't need that anymore. So we now have a string that we can actually draw. Well, how do we do that? We obviously need to draw that letter by letter, as you will remember. So maybe we first write the code to actually draw a single letter. So to do that, we want a function that can draw a single letter, a function or a block that can draw a single letter. So we go here to variables, we say make a block, and we need to decide what that is. It's a command down here, and in which section we want to list it. Looks actually is probably where it belongs. Okay, what do we call it? Let's call it process character. And you see we get this block editor here where we can now add our code. Now process character needs an argument because it needs to know what to actually draw. So let's add an argument by clicking on that plus, and let's call that argument letter. Right. So the first thing is obviously to decide which letter we actually have, and we do that using a decision command, an if. We get that from the section control up there, and we can now identify which letter we have. So you remember we had zeros, ones, pluses, and minuses. Let's just start with the zeros and the ones, and they both just refer to drawing a line segment of 10 steps. So we go to operators to get a comparison. If, drag the letter from here into that box, if letter equals 0, then what do? We use our turtle graphics and we just go 10 steps forward. And we're already done with that particular letter. Now we do the other ones. Well, if it was a 1, that actually meant exactly the same thing. So let's duplicate this. And let's just change that here. If it's a 1, we do the same thing. Now we also have pluses and minuses. Let's make that more efficient. Go back to the control, and we do first all the ifs. If we have a plus, if we have a minus, and then we also had the closing and opening brackets, and we shall fill this in a second. And that's pretty much it. So let's copy over these letter comparisons. In there, duplicate. Remember, you're getting this duplicate command by control clicking on the block. Okay, we fill these in with the plus, the minus, opening bracket, and the closing bracket. Now the plus and the minus refer to actually changing directions, and of course in Turtle Graphics you get a command for that, and that's here in the motion section. So the plus was turn clockwise, and we used 45 degrees in our example, and the minus was turn counterclockwise by 45 degrees. Now the other ones were a little bit more complicated because they refer to using the stack. We don't have a stack yet. So maybe we first actually need to define what a stack is. So let's get rid of this for now here, the process character, and we'll come back to that later. And let's work a little bit on the stack. Now you may have guessed that to represent a stack we first need a variable. So let's do that. Let's make a new variable, and we shall call it stack. and by default, press OK, by default it's displayed up here. Now, the best data structure to represent a stack is actually a list of items. And if you put something always at the front of the list, a new item, and then you also take it from the front of the list, you're getting exactly the effect of the stack. The last thing that went in comes out first. So let's do that. We first of all need a function to make a new stack. Right? Let's do that. We go back, make a block. We put that, let's say, into the variable section, and it is a command, and we call that clear stack, which makes this stack variable there an empty stack. And to do that, what we need to do is we need to set the stack variable, and we need to set it to an empty list. And we do that by grabbing the list from here, reduce that by clicking on the left arrow. So that's a list with no items, an empty list. And we're done already. Now the next thing that we need to do is we need to have a function to push, or a block to push an item onto the list. So we'll make another block, and we put that in the same section, in the variable section, and we call that push. Of course, to push we need to know what to push, so we're generating an argument by clicking on the plus. Let's call that the item that is to be pushed, and what we need to do in there is we set the stack to what it has been before, so that's the stack itself. Let's grab that, which is a list that has something in it, but we want the new item in front of what's already in stack. Well, there is actually a function that does exactly that, that combines the current contents of stack with item, that was the in front of from over here in the variable section, and now we just need to set the stack to that, and we're done. Press OK. We have our push, and now what we need, of course, is also the pop function. The pop function, which gets an item back from the stack, and it needs to get the first item out of the stack, and also it needs to reduce the stack so that that item then is gone. So again, we make a block in the variable section, and we this time using the reporter, which means it will actually give us something back, namely that item from the stack rather than the command, and we call it pop. It doesn't need any arguments because the stack is in that variable. So what do we need to do? Well, we need to reduce the stack, so we need to remove the first item from the stack. So of course we need the set stack again, and we want everything but the first item, and there's a function for that here as well, all but first item of the stack. So we drag that stack variable from up here into that. So that will reduce the stack. But before we do that, we actually need to extract that item. We can't just throw it away, we want to return it down here. So to do that, we make a new variable, but we use this script variable here, so the variable only lives in that script and doesn't exist outside. So you see it's not listed up here, it won't be displayed, it just lives in that script. So we have a variable a that we can use for that, and we will set that variable a to the first item of stack. So we use this function here, item 1 of stack. Grab that from here, fill that in. Okay, so pop defines a script variable, sets that script variable to the first item of the stack, then sets the stack to itself with that item removed, and finally it needs to return that item that it had removed, which is now in the variable a. Done. Okay, let's test this. So we get all our new functions, put them over here. We first clear our stack, and you see we have a list of length 0 now here. Then we push a few items. Let's say we push John, click to execute. We push Emma, and we push Jerry as names onto the stack. Could be anything. And you see that Jerry is the first because it was pushed last. Now, if we pop something, the first item disappears again. So we pop, and it's returned Jerry, as you see down here, and it's removed from the stack. Next one that we pop is the first one, which is Emma, removed from the stack. Next one that we pop is John, and now there's nothing more to pop. Okay, so our stack functions actually seem to work. Let's get rid of them again from the workspace. And now we can actually proceed with defining the drawing functions. So our drawing function was in the look section, process character, here it is. Control click on it, go back to edit. There's your definition again, and we still had to fill the ones for the brackets, which is where we need the stack. So what we need to do is for the opening bracket, we need to push the X position, the Y position, and the direction that we're currently heading in. You will remember. So let's do that. We go to the variable section. We go push 3 times. And the items that we want to push, they are in the motion section. So the first one is the X position, just down here. Second one is the Y position, and the third one is the direction. Everything that our turtle needs to know to move properly. Now for the closing bracket, we do the opposite. We pop the variables, which is the X position, the Y position, and the direction. Get 3 pops from down here. Now think for a second in which order you need to pop them. Last one to go onto the stack comes off first. So the first one is the direction. So we're popping the direction, and what we want to do is we want to set the direction again in the old direction. So point in direction from the motion section, whatever we get back from pop. And then we want to set the X and the Y. Rather, we want to set the Y first because that was pushed onto the stack later. Set Y to whatever you get from the stack, and set X to whatever you get from the stack. And we're done. Well, actually, we're not done, because if you do this and you come back from a totally different point to an old X and Y, the turtle will still be drawing. So you get a line that goes right across your screen sometimes. So before we restore these positions, we need to take our pen up, and after that we need to put it down again so that we can continue to draw. So pen up, restore everything without drawing, and then pen down to continue drawing. And now we're actually finished with our process, the character. So this is, this is the whole function. But of course we don't just want to draw a single character, but this whole string up here. So somehow we need to go through that string character by character and call our process character function for each letter. So let's write a new function for that. What shall we call it? We need to go to the variable section to find our maker block, and we shall call that, let's say, draw string, draw the whole string. That is a command because it does something. It doesn't return anything, it just does something. And we'll put it into the look section together with the process character. It doesn't need an argument because we have that variable here, string, that tells us what to draw. So we need to go through the string one by one, and for that we need an index into the string, which needs to be represented by a variable. Let's therefore generate a script variable, and it's common to use an I for an index, so we'll do that here. Okay, so what do we need to do? We go through the positions of the string, position 1, 2, 3, 4, 5, 6, 7, and so on and so forth until we're at the end. Let's do that. We use I to give us the position that we're currently looking at. So we say set the script variable I to 1. That's where we want to start, right? And now we do the same thing over and over again, for which we need a loop as a control structure. And the natural thing here to use is the repeat until. Repeat until you're at the end of the string. Now the end of the string, well, you still need to process the last letter, but as soon as your I points one letter longer further than the string is long, you're done, right? So what you want to find is the length of the string, somewhere here, length of the variable string, and you want to see whether I is greater than that. So we'll take a greater operator, and the script variable I goes in here. If I is greater than the length of the string, well, then we're done. And within that now, we need to process one letter, so we had that in the looks, process, character. Which character is it? Well, it's the ith letter of the string. So under operators, we find a function to extract the, here it's letter 1 by default. Now we take the ith letter and we want that of string. So I'll go to the variable section, drag the variable string into there. Process character, letter I of string. But then of course we need to increment I to go to the next position. So set I to I plus 1. Get a plus operator from here. I plus 1. And we're done. Well, probably not quite yet. To draw a string, you take a variable I, you start with the value 1, and you keep iterating by incrementing the variable with 1, adding 1 to it, processing the character and in the string at the position that it points to, that index I points to, and then you continue like that until your I is behind the string, in which case there's nothing to do anymore. All right. Is that all that we need to do? Well, I think we need to do some preparation work. So remember, one thing is that we actually have that stack where we're pushing and popping positions. So that still needs to be initialized. So we need a clear stack. But we made a command for that, which is down here. So we'll just do that as the first thing. Clear the stack. And then of course we also need to prepare our turtle, right? So let's go to the look section. One thing that we can do, this is kind of optional, but we don't really want to see the turtle as it is drawing, so we hide that. We need to clear the old picture if there's anything. And want to go to our starting position, we need a goto command. Just say go to x0, y0. We want a fixed starting direction, so let's say we take this here, point in direction 90 degrees, could do something else. But then the same as when we pop from the stack, when you go there, the turtle will actually draw, and you don't want that. So you need to take your pen up before and pen down to actually start drawing afterwards. Connect all your blocks. And now we're really done. To initialize, clear the stack, hide the turtle, clear the picture, take the pen up so that you don't draw, go to your defined starting position, point in a defined starting direction, put the pen down so that you can start to draw now, and Here you might do other things like set the color and whatnot, and then iterate through the string to draw each letter of it. So we're done. So let's test whether it actually works. We'd already pasted the string from the lessons up there into our variable, so all that we need to do is to attempt to draw it. Our functions were in the look section. There's draw string. Let's just call it. And you see, voila, it draws what it's meant to draw. So it works. And you may have seen that something was happening there in the stack. We could do that again. Let's go to pen and just clear the whole thing. Start again. Watch the stack window. So stuff happens there, and that's all that I wanted you to see. As the plant gets drawn, things get pushed and popped onto the stack, and it's done. It's fulfilled its function. Okay, we could get rid of those variables because they're just in the way. Well, not actually get rid of the variables, just get rid of their display by unticking them here. And for the last time, because it was so nice, clear this and now draw the string with nothing in the way. Good. So we're done. You could now draw any other string, but of course, if the string contains any other characters, you'll have to redefine or extend that process character here to draw them in the way that you want them. And we'll come back to that later at the end of the lesson.